Welcome back to Conversions. Today we're going to look at how to do a 2-unit or a rate conversion using what we've learned from the prefix table system and setting up a conversion chain identity process. When you're given a rate, feet per second, miles an hour, centimeters per second, things like that, oftentimes in the actual problem or on the document, the expression or the value will be written like this, kilometers/hour. That is just a holdover from when this stuff was initially done with typewriters. And it was very difficult to have one value over the other because of what it did in the line spacing. So this is just a shorthand for fraction. It's really important you know how to set a rate conversion up to get the conversion correct in the end. So let me kind of show you how we do this. Our goal is going to be going from 40 kilometers an hour into an equivalent number of miles per second. Why did I go miles per second? I have no idea, but I didn't want to give you miles an hour again because it's too easy. When you write this, you must write it this way to minimize the likelihood you're going to mess up the conversion. 40 kilometers an hour means that this object travels 40 kilometers in 1 hour. So I've specifically set this up. That is a fractional structure, so kilometers per hour. Now again, our goal over here is miles per second. I'm going to use MI for mile because I don't want you to confuse it with meters. Second could just be the S. With a rate conversion, because everything is multiplication and division, it doesn't matter which one you do first or second. So order doesn't matter. So I'm going to look at the kilometer one first, and I'm going to get this into miles. Now, it looks like I'm actually giving you a fairly easy one because there's a conversion we can use on the prefix chart that tells me how many kilometers equal 1 mile. So I'm just going to write it down here fairly large so we can take a look at it and say that we know that 1 mile, which is an English measurement system unit, measurement, is equivalent in the metric system to 1.61 kilometers. So that equivalency can be written this way, and it means the same thing. Or you write the fraction the other way, 1.61 kilometer over 1 mile. You just have to set it up so remember, we're going for miles, we got to get rid of kilometers. So if there is a conversion identity that we can use that takes us from kilometers to miles, I'm gonna jump all over that first, so I'm done with that process. And from a mile to a kilometer, yeah, we got it. So it's important as to how you write this. It says that there are 1.61 kilometers in every 1 mile. So once I do that, I'm going to look at this, and those are gone, and my n unit is miles. I go over here. That's our goal for the n unit of length, so that's done. This is easier than I thought. Oh, too bad. So you got a break on this one. Now, we're going to seconds, so we're traveling from a larger unit to a smaller. We want to cancel out hour. The next smallest time unit is the minute, so MIN. Now in 1 hour, there are 60 minutes. So now the hour is canceled. And we want to go from minutes to seconds. Now be careful, don't get this wrong. There aren't 60 minutes in a second here. Second is a smaller unit. 60 little things make up one big thing. So 60 seconds is equivalent to 1 minute. Now let's see, we've canceled the kilometers, we haven't canceled that. Hours are gone, minute, minute. So our end unit is seconds, so we are done with the conversion, and as long as we have the values in the correct spots, we should be good. So we're 40 times 1 times 1 times 1. Oh, that was redundant. Divided by 1, super. Now divided by 1.61, divided by 60, divided by 60. Now notice what I did when I just said that. I did this, divided by that, divided by that. So I didn't do like divided by and then try to multiply them. As long as you keep doing divided by, you're telling the calculator, this is in the bottom, this is in the bottom, this is in the bottom. If you don't do that, you've got to bracket those numbers so that the Casio or the calculator knows these are grouped together to multiply, and I'm dividing by them. The number I end up with, I'm going to go right to sign naught with this, because that's how my calculator decided to give it to me, because it's, I don't know why I did that. 6.90 times 10 to the negative third miles per second. I typically go to 2 decimals in these answers when I do them. That is my final answer. A final talking point here is, why did I do the length first and then the time? No reason. I have a tendency to always look at the top value first and then do the bottom one second. Second observation is this one. Pay attention to the hour unit down here, the time unit. Now it doesn't touch the first or second conversion identity. It touches, let's see, oh it does, it touches the second one. I apologize. Notice how this one physically isn't connected to that. It doesn't need to be. As long as when you're done with one conversion, say the length conversion, that you start the next identity where it's supposed to be so the cancellation happens. Okay. I've often seen people, and I've taught this way, that if I have 2 units that I'm converting, you can run the length conversion this way, and you can do your time conversion that way if you like having them touch. You're still going to do one big fraction at the end. So as long as you do the conversions through their entirety, you should be all set. And it doesn't matter if you do the top first or the bottom first, as long as you follow the process to completion before you start that second unit conversion. So that's it for rate conversions. I hope that helped you out. Have a good day.